You ever wonder how Google just knows what you're looking for? You type a couple of words and boom, millions of results in milliseconds? It looks like magic, but it's really decade of clever engineering built layer by layer back in the early 90s. When Tim Berners-Lee invented the World Wide Web, the internet was so small, he literally kept track of websites in a notebook. Early search tools like Halliweb or Yahoo Directory were basically phone books. Human created lists, simple but quickly overwhelmed. The web grew explosively, nobody could keep up manually. The first big problem, how to automatically discover what was out there. Solving this would require a smarter approach, and it became clear that whoever cracked it best will build one of the most influential companies ever. And that got me thinking, could I recreate the core steps, build a mini search engine today? Just the essential part, pull the web, index pages, rank them, and let people search. All in just 1 week. No Google scale server, just me, a laptop, and a stubborn curiosity to understand those layers of engineering. Step 1. Solve that discovery problem with a web crawler. This idea isn't new. It dates back to projects like Matthew Gray Wanderer at MIT in 1993, which tried to map the Hollywood. The core idea is simple. Send a bot to explore. Start with a few seed sites, grab the contents, extract links, follow those, and repeat. It sounds simple, but solving one problem introduces others. From one page, you might find dozens of links, from those 100 more. It's exponential. Soon, you have a massive list of URLs to visit. Visiting them one by one is painfully slow. Okay, new problem. Speed. Solution? Run multiple crawlers in parallel. But wait, that creates another problem. If all my crawlers hit the same website at once, I could overload the server. Basically, a mini DDoS attack. That's illegal and definitely not playing nice. So, the refined solution. Implement politeness. I kept track of the last time I visited each domain and made sure my crawlers wait a reasonable time before hitting the same domain again. Crawling isn't just about speed. It's also about respect. Site have a robot file, rules saying, hey bots, you can look here, but please don't look there. We must check and obey this file for every site. And finally, resilience. What happens if the crawler crashes? We can't lose all that progress or the giant queue of URLs. So I use a small database to keep track of visited URLs and manage the queue. In 2 days, the crawler was running, discovering thousands of pages, grabbing basic HTML and saving it. But now we have a new problem. Tons of raw data, but no way to search it quickly. If someone searches for chocolate chip cookie, how do we find the relevant page quickly? Reading through every single page for every search word will take forever. The solution is an inverted index. Think of it like the index at the back of a textbook or a reverse phone book. For every significant word anchored across whole crawl page, we store a list indenting which page it appears on and maybe how many times. Building this involves processing each saved page, tokenizing it, cleaning it, maybe stemming word, and counting the frequency of each remaining word. This all goes into our index database. Now, when someone searches chocolate chip cookie, we don't scan pages. We jump directly to the index entries for chocolate, chip, and cookie, instantly getting list of pages containing those words. This creates the next big challenge. We have matching page, but which one are the best? Which should come first? Okay, the index gives us a list of pages containing the search term, but how do we decide the order? This is ranking. The simplest idea? Count how many times a keyword appears, but that's easily gamed. You could just spam best cookie recipe 500 times in a white text on a white background. Plus, a relevant page mentioning cookie 5 times might only rank higher than a short focus page mentioning it 3 times. This simple solution is flawed. We need something smarter. Enter TF-IDF. It sounds intimidating, but it tackles this issue head on. TF for term frequency. Look at the proportion, how often does a term appear relative to the total number of words on that page. IDF, inverse document frequency, is how common or rare is the term across all pages with index. It gives more weight to rarer, more specific terms. Multiplying TF by IDF gives a relevance score. Page where the search term is frequent for that page length and where the term itself is relatively uncommon overall, rank higher. Even TF-IDF only looks at the page contents. What about authority or reputation? How do we know if a page is trusted? This is the problem Google tackled brilliantly in the late 1990s with PageRank. The idea from Larry Page and Sergey Brin was to use the web links structure. Hey, links from page A to page B act like a vote for page B. But couldn't you just create thousands of fake pages linking to to your site? Yes. The genius twist was that vote from important page could more. If page A itself was highly linked, its vote for page B carried more weight. That was revolutionary. It used the web collective judgment to measure reputation. I didn't implement the full complex PageRank, but I added a basic system. Incoming links give pages a small authority boost, which I combined with the TF-IDF score for a final ranking. It's like high school popularity, but for HTML. Pages that are relevant and reasonably popular bubble to the top. Alright, the core components are there: crawling, indexing, and ranking. The final step for this week was to make it usable. I built a simple API. It's a small web service that listens for search queries. When a query comes in, it consults the index, calculates the TF-IDF, and links score from matching pages, sort them, and send back to the top result. Then, I put together a basic frontend, a simple web page with search bar. When you type a search and hit enter, some JavaScript called my API get the rank list of pages and display them. It's not Google, not even close. The index is tiny, the ranking is rudimentary, but look, it takes a query and returns rank result from web pages. It's actually crawled. The basic loop is complete. It works. So, can you build a search engine in 1 week? Yes, a very basic one. And honestly, it's way more fun and educational than I expected, revealing the layers of problem and solutions involved. What layer will you tackle next? Should we try render JavaScript, improve the ranking algorithm? Let me know your idea in the comments. If you enjoyed this project and learned something, smash that like button. Hit subscribe for more coding adventures, and I see you in the next build.